All right, so today we're going to talk about the Honors Algebra 2 Edgenuity Section 7.4, which is called Adding and Subtracting Rational Expressions. There are two objectives in this section. The first is to perform addition and subtraction of rational expressions, just like the title says. The second is to simplify complex rational expressions containing sums or differences. So to add and subtract more complicated rational expressions. All right, so here we go. Let's look at our first problem. We want to simplify, that is, just subtract this problem here. And when I look at problems like this, when I look at subtraction problems, the first thing I think is, what happens if I lose track of the fact that that really represents a negative? For example, we're really doing a negative times a negative there, but it's kind of hard to see with that minus. So if I do plus negative instead, then you can more clearly see that I've got negative times negative. And it gives me a new problem, or a new way to look at this problem, at least. X squared minus 2x minus 3, 2x over x squared minus 2x minus 3, plus negative times negative is positive, so this is positive 2 over x squared minus 2x minus 3. Now, what we did in a previous section is we took everything apart as much as possible and looked to cancel things. We're still going to pull everything apart as much as possible, but we won't necessarily be looking to cancel things. I mean, if it happens, that might be a good thing, but remember, we're adding and subtracting now, so we're going to need common denominators. So if you look, our denominators are already the same, but for purposes of getting the practice in, I want to try to see if I can factor this expression here into two parts, because it's going to be helpful as we move into other problems. So to make the x squared, I do x times x. If there's a minus or a negative there, one of the operations is plus, one of them is minus. And then I need two numbers that multiply to make this, and do this to make this number. So two numbers that multiply to make 3 and subtract to make 2 are 3 and 1, right? 3 times 1 is 3. 3 minus 1 is 2. And then the bigger number goes with that sign. So 3 there and 1 there. Plus 2 over, and of course this one's the same, so it'll factor the same into x plus 1 times x minus 3. And then, once you have common denominators, all you have to do is take the numerators, the top parts, and add them together under one fraction. So 2x plus 2 over that common denominator of x plus 1 times x minus 3. This is a perfectly acceptable answer right here. But you might want to consider the fact that there is indeed a 2 in this that could factor out, and so another acceptable answer might be 2 times x plus 1 over x plus 1 times x minus 3, and what you should see is that now x plus 1's cancel. And so now I get an even better answer, an even more succinct answer of 2 over x minus 3, because I was able to cancel those x plus 1's. Okay, so that is that one completely simplified. I'll pause for a moment, let you look at that, see if there are any questions. Okay, there being no questions, I will move on. All right, so now we've got everything with an x minus 3 in common in this next one. So if we have that common denominator, let's just put the three things at the top together in one fraction, because I certainly can't factor that x minus 3. But maybe I'll be able to factor other things as we go on. So let's just do 2x plus 1 plus that x plus the 4, all of that over the common denominator of x minus 3. So what does that allow us to do? Well, that allows us to put together the x's, and let me, because it's all addition up here, I can add in whatever order I want. I can put whatever I want next to each other. So let me do 2x plus x, organize my x's together, and then organize my constants, my numbers without variables, together. And then I can put this together. 2x plus x is 3x. And put that together. 1 plus 4 is 5 over x minus 3. And then you want to look at it and go, well, can I factor this at all? And if I do factor it, will it give me anything that cancels? And it turns out that you can't factor any of that, so we're just left with this as the answer. I'll pause for a moment, let you look at that, see if there are any questions. Okay, there being no questions, I will move on. All right, so now, again, we've got common denominators, but maybe something that could factor. And we've got a minus. And again, I'm going to take this minus, and I'm going to make it plus negative, and I have to be careful here, because it's the negative of that whole thing. And I'm even going to take the minus that's inside and call that plus negative, and the minus that's over here with the 2x minus 8, and call that plus negative. I'm not doing it down here, and the reason I'm not doing it down there is because I want to factor that, if possible. And it's a little bit easier to look at and think about the factoring with minus signs. It just helps me, at least. So here's what I'm going to do. I've got my 2x plus negative 8 over, and I'm going to see if I can factor into two parts. I need the x squared, so that's x times x. If there is a plus right there, then both the operations are that. So minus and minus. And then I need two numbers that multiply to make this, and do this to make that number. And those two numbers are 2 and 5. 2 times 5 is 10. 2 plus 5 is 7. So I need a 2 and a 5, and it doesn't matter where I put them because they're both x minus there. So I've got that, and then plus, and let me distribute the negative there, giving me negative x plus positive 3, and that is the reason that I turn all my minuses into plus negative, is so I can keep track of things like that, so I can know when I'm going to have a positive 3. Over, and then we've got the x minus 2 times x minus 5. And then let me take the top and put them together in one fraction under this common, over this common denominator. So it's 2x plus negative 8 plus negative x plus 3 all of that over x minus 2 times x minus 5. Okay, let's put things together then. I could put the 2x plus the negative x together. That would give me 1x, or just x. I could put the negative 8 and the positive 3 together, and that would give me negative 5, and that's over x minus 2 times x minus 5, or x plus negative 5. So this actually cancels that. And if I'm left with nothing on the top, I'm left with a 1. And then on the bottom, all I've got left is the x minus 2. And there it is. I'll let you look at that for a moment, see if there are any questions. All right, there being no questions, let's move on to the next problem. Let's talk about simplifying this one. Now, here's a situation where we do not have common denominators. And you can only get common denominators through multiplication, right? If I were doing 3 over 4 plus 2 over 3, I can't just go, oh, well, I'll just add 1 to that 3 and that'll be good enough. I have to multiply this side by 3 over 3, multiply this side by 4 over 4 to get the common denominator. That's the only way you can get common denominators, is through multiplication of clever forms of 1, right? 3 over 3 is 1, 4 over 4 is 1. So this plus 1 is sort of there to test that idea. But I can only do multiplications. So what I'm going to do is I'm going to say, okay, I've got this whole thing. I'm going to treat that as a collected thing. And I'm going to multiply by that whole thing over here. And then over here, I'm going to multiply by this x squared over x squared. And that's going to get me a common denominator. So what I'm going to have is 4 times this quantity x squared plus 1 over that x squared, this x squared right here, times that quantity x squared plus 1, plus 5 times that x squared right there, over that same x squared times x squared plus 1. So now I've got common denominators. So now I can do things like distribute up here, put this together, and write it all as one fraction. So I would have 4x squared plus 4 plus 5x squared. All of that over the common denominator of x squared times x squared plus 1. Now, you could, if you really wanted to, you could distribute in the denominator in the bottom. However, I would tell you to hold off on that instinct in these types of problems, because if you keep things apart, you may wind up seeing that things cancel, okay? And sometimes they will and sometimes they won't. They have so far, but you're going to see that they actually don't here. So if I put 4x squared plus 5x squared together, that makes 9x squared. Those are like terms. And then I've got that plus 4 over the x squared times x squared plus 1. And then you look and see, can I factor this in any way that might be helpful to cancel stuff here? Well, I can't factor that at all, right? It's not a difference of squares, so I can't factor it that way. And I can't like factor a 4 out or factor a 9 out or factor an x squared out because they're not common to everything in the expression. So then that means that this winds up being the answer. I'll let you look at that, see if there are any questions. All right, there being no questions, I will move on. Let's talk about this one. Now this one I want to show you something. So I was just talking about you need to do multiplication to get common denominators. So take a look at this one sort of carefully. It's 2 over x plus 3 over x squared, but x squared means x times x. So if I look at this carefully, I've got an x and another x multiplied there. So I've only got one x there, but I could multiply by x to make the second one. I could do multiplied times x over x. Clever form of 1, right? And then I would have x times x here and x times x there. So it turns out that in this particular case, I don't need to do anything to this one, that is, to this one, to get common denominators. So I do x times 2, which is 2x, over x times x, which is x squared, plus 3 over x squared. I'm just putting this back together since it doesn't really do me any good to take it apart. And now I've got common denominators, and I can put the numerators, the top, together. So I can say that's 2x plus 3, all of that over the common denominator of x squared. And again, you want to look to see if things can cancel, but remember, you cannot cancel things between addition or subtraction. So I can't cancel this x with one of those x's because of that plus right there. That plus means you'd have to find this whole thing on the bottom to cancel it. So then it turns out that this just is the answer. There is no more cancellation to do. I will pause for a moment, let you look at that, see if there are questions. There being no questions, I'll move on. So now let's talk about one of the more difficult situations with not having common denominators. Okay, let's take a subtraction problem, and let's take two denominators that are actually different and that are going to have to be factored. Okay, so the first thing I'm going to do is I'm going to take the minus, I'm going to call it plus negative, and I can put that negative up top there with the 1. And the next thing I'm going to do is just try and factor these two expressions in the denominators. So for this one, for example, I'll need x times x to make x squared. The minus here means that one of these will be plus, one of these will be minus, and then I need two things that multiply to make 10 and subtract to make 3. So two numbers that multiply to make 10 and subtract to make 3 is 5 and 2. 5 times 2 is 10. 5 minus 2 is 3. And then the bigger number goes with that right there. So the 5 goes there and the 2 goes there. So, okay, good. I'm going to leave some space because we're going to need some space. And then plus negative 1 over, and now I want to factor that. So to get x squared, I'd need x times x. If there's a plus here, they're both that. So they're both x minus, and x minus. And then two things that multiply to make 5 and add to make 6 are 5 and 1. It doesn't matter where I put them. And then you look at it again. And you ask yourself, okay, what's missing from this that is over here? And likewise, what's missing over here that is over there? So for this one, I've got an x minus 5 the same, but I'm missing the x minus 1. So what you do is you multiply top and bottom by that x minus 1. And that gives you everything. And likewise over here, you're missing the x plus 2, so multiply the top and bottom by x plus 2. And once you've done that, you'll see that we have all 3 over here and all 3 over there. And that really gets us what we need. That gets us a common denominator. Okay? So then on the top, let me show what we have here. We have 3 times x minus 1 as a quantity, plus, I'm going to put these together as one fraction, negative 1 times x plus 2. All of that over this common denominator of x plus 2 times x minus 5 times x minus 1. And then I want to distribute. And before I distribute, let me take that minus and turn it into plus negative, just to help keep track of all my negatives. So I'll distribute there, I'll distribute there, giving me 3x plus negative 3 plus negative 1 times x is negative x plus negative 1 times 2 is negative 2. All of that over that common denominator still of x plus 2 times x minus 5 times x minus 1. And now put like terms together on the top. So we've got 3x plus negative x, which will be 2x, and negative 3 plus negative 2, which is negative 5, over that common denominator of x plus 2 times x minus 5 times x minus 1. And you could consider taking that x plus negative, or that plus negative 5 and making it minus 5, but still you wouldn't be able to cancel anything, right? Because to cancel you'd need exactly an x plus 2, or exactly an x minus 5, or exactly an x minus 1. And we're not going to be able to factor anything out of that to make that happen. So this is our most simplified answer, barring that you might make it 2x minus 5. I'll pause for a moment, let you look at that, see if there are questions. All right, there being no questions, let's move on to the next one. Another one, kind of just like it. Okay, so we've got 2 over, and I want to factor that one. So x and x, and then 2 numbers that multiply to make 4, subtract to make 3. Oh, and a minus here means one of them's plus, one of them's minus. So 2 numbers that multiply to make 4, subtract to make 3, that's 4 and 1, with the bigger one getting that sign, so 4 there, 1 there, plus 3 over, And, oh, let me make a little more room there, because I'm going to have to do some multiplication. So plus 3 over, try and factor this one. And remember, you're always trying to factor. You're always hoping these will factor. To make x squared, I need x times x. Plus here means they're both that. So minus and minus. And so two things that multiply to make 8 and add to make 6 are 4 and 2. And so they have the x minus 4 in common, but this one additionally is going to need the x minus 2. And this one additionally is going to need the x plus 1. So then now I have 2 times x minus 2, or x plus negative 2, plus 3 times x plus 1, all of that over that common denominator of x plus 1 times x minus 4 times x minus 2. By the way, I'm not worrying about multiplying these together because, number one, it's a long process. Number two, it might turn out that I can cancel things. So usually you don't wind up putting them back together. Sometimes, but it's not very typical. So let's distribute. That'll be 2 times x is 2x, plus 2 times negative 2 is negative 4, plus 3 times x is 3x, plus 3 times 1 is 3. All of that over my x plus 1 times x minus 4 times x minus 2. So that equals, let's put like terms together, 2x plus 3x is 5x, plus negative 4 plus 3 is negative 1, and all of that over my common denominator of x plus 1 times x minus 4 times x minus 2. And again, I might change plus negative back into minus. I'll show that this time. And keep that common denominator. And you'll notice again that the top won't factor. I can't like factor a 5 out of it or anything like that. So there's not going to be any cancellation. So that is the final answer. I'll let you look at that for a moment, see if there are questions. All right, there being no questions, so I'll move on. So let's take a look at this one. Again, minus right there, I want to change to plus negative, and I'll put the negative right up there with the 3. And I'm going to want to factor this. So why don't we start by doing that. I'll leave some space to do some multiplication. Leave some space again to do some multiplication. And then 7 over, let's see here. So to make x squared, I need x times x. A minus here means one of them is plus, one of them is minus. And then two things that multiply to make 12 and subtract to make the 1 that you don't see but is understood to be there is 4 and 3, and the bigger one goes with that. So plus 4 and minus 3. And so that's convenient because now I know to get common denominators, I just need x plus 4 times x minus 3 for everything. So I'll just multiply in the x plus 4 over x plus 4 there. That gives me the x plus 4. I'll multiply in the x minus 3 here over x minus 3, and that'll get me the common denominator there. And so I'll have x times x plus 4 plus negative 3 times, well, at the top, let's call that x plus negative 3. Help me keep track of my negatives. Plus 7. All of that over that common denominator of x plus 4 times x minus 3. Let's do some distribution with all of these and get x squared plus 4x plus negative 3x plus 9. Negative 3 times negative 3 is 9, positive 9, plus 7 over x plus 4 times x minus 3. And so let's put like terms together, and then we might look to factor. So that'll be x squared plus, put the 4x plus negative 3x together to be 1x, or just x. And then I'll put 9 plus 7 together to be 16 over x plus 4 times x minus 3. And then we want to look at it and see, is there any way to factor this? Well, let's take a look. I would need x times x to make x squared. If there's a plus here, they're both this, so it's plus and plus. And then I would need two things that multiply to make 16 and add to make 1. Well, those don't exist, so it's not going to factor. So that is my final answer. I'll let you look at that, see if there are questions. Okay, there being no questions, I'll move on. And let's look at, so I have an issue with these types of problems, and that issue is that they call them complex rational expressions. They're not complex. They're complicated, but complex in math really implies that we're going to have I, the imaginary number, in there somewhere, and we clearly don't have that here, so I don't like calling it complex. I like calling it complicated. So when you have these complicated problems with fractions inside of a bigger fraction like that, the strategy is turn it into one fraction, turn it into one fraction, and then turn it into a multiplication problem. So let's concentrate on turning this into one fraction. I need common denominators in order to do that. So this part is missing a y. This part is missing an x. Same thing down here. This is missing a y. This is missing an x. So I'll make all those adjustments and look at it again. So that would be y times 2, which is 2y, plus 3 times x, which is 3x, and I can make that all one numerator, one top, over the common denominator of xy, over, excuse me, y times negative 5 is negative 5y, plus 7 times x is 7x, all over the common denominator of xy. And then we do keep, change, flip as our way of remembering how to change division into multiplication. You keep the top, so I'll keep that top fraction. I'll change division into multiplication, and then I will flip the bottom fraction so that it looks like that. Now notice I've got an xy here, an xy here, and so I can cancel those two xy's. And now I'll have 2y plus 3x over negative 5y plus 7x. And I can't factor either one of those. The most I might be able to do is take this and call it 7x minus 5y, but I mean, I suppose we could put our x's at the front and do that if you really wanted to. But this is as good of an answer as this, especially if you can see that they're both the same answer. I'll pause, let you look at that, see if there are any questions. Okay, there being no questions, we will go on to the last problem. All right, so in the last problem, we've got a lot of factoring to do. Okay, we've also got a lot of minuses that we might want to change into plus negatives, like plus the negative of that whole thing, plus the negative of that whole thing. Okay, so let's do some factoring. 2x plus 5 over, I can factor an x out of that. So I'll factor an x to the front, and x squared divided by x leaves me with an x, minus 3x divided by x leaves me with just a 3. Plus, and I'm going to distribute the negative up at the top there. So I have negative 3x plus negative 5. Again, that helps me keep track. And again, down here, I can factor out an x. The whole thing has an x in common. So I'll factor an x to the front. And if I do x cubed divided by x, that leaves me with x squared. Minus 9x divided by x leaves me with just a 9. Plus, and I'll distribute this negative plus negative x plus negative 1 over, and I see that x squared minus 9, but x squared minus 9, you might recall, is a difference of squares, and difference of squares, that is this squared minus this squared, is the square roots in each factor part added once, subtracted once. And I'm going to have to do that with this one also. And so let's do that in the next step, and then we'll start leaving room for other stuff. So x times x minus 3 with some room for multiplication. And then negative 3x plus negative 5 over x times, and I'm going to break that down into x minus 3 and x plus 3, that difference of squares, and leave a little room in case we need multiplication, plus negative x plus negative 1 over x plus 3 times x minus 3. And then you look at them and go, okay, what's missing from each one? Well, you might notice that there's an x minus 3, there's an x plus 3, and actually in this middle expression here is all three of those. So actually the middle one doesn't need any more multiplication. The middle one I can leave alone. But the first one should be pretty clear, is missing an x plus 3. And the last one, it should be pretty clear, is missing an x. And so now I've got 2x plus 5 times x plus 3 plus negative 3x plus negative 5 plus negative x plus negative 1 times x, all of that over that common denominator of, let me make that a little bit nicer looking, x times x minus 3 times x plus 3. And then you got to do some more work. This has to be multiplied together. This has to be distributed. And then you're kind of hoping that once you do all that work, that things factor and that you can cancel things. So I'm going to do this multiplication. We'll do this distributed to both of these, and then distributed back. So 2x times x plus 3 is 2x times x is 2x squared, plus 2x times 3 is 6x. So I did this, and then I took this and did it to both of them, because that's what would be required. And then the same thing with the 5, so plus 5 times x plus 3 is 5x, plus 5 times 3, which is 15, plus negative 3x, plus negative 5, plus negative x squared. I'm distributing the x there, plus negative x, or negative 1 times x is negative x. All of that over x times x minus 3 times x plus 3. And we're going to run out of room here, but I think we'll have just barely enough room. So 2x squared plus negative x squared is positive 1x squared, or just x squared. And I usually keep track by crossing things off. Plus, let's see here, we've got 6x plus 5x plus negative 3x plus negative x. So that's going to be 11 plus negative 3 is 8x plus negative x is 7x plus 15 plus negative 5 is 10 over x times x minus 3 times x plus 3. And then does this factor, and if it factors, does it factor into anything helpful, anything that would cancel? So I'm just going to explore up here. Bx times x, they'd both be plus. 5 and 2 works. 5 times 2 is 10. 5 plus 2 is 7. However, it's not helpful because that doesn't help me with anything canceling down here, so I could just leave it like this. I'll pause and let you look at that, see if there are any questions. All right, that was our final problem. Thank you for listening.